Let's get started looking at the metric system. First of all, just an interesting little bit of history. This is something I found on the internet. This is the Act of Congress that was passed in 1866 that makes the use of the metric system legal, not mandatory, just legal in the United States. Now, the metric system was originally introduced as a way of putting measurements into the same system as the numbers we've counted. Because, for example, you have 1 foot is 12 inches, 3 feet in a yard, and none of the units make any kind of sense in the way that they are regular. You have to just memorize each of the different units and their conversions. There were some useful features, for example, 12 inches in a foot. Well, 12 inches is divisible by 3, it's divisible by 4, it's divisible by 2, it's divisible by 6. So it makes a certain amount of sense in doing math with fractions. But the metric system was formed or invented to use our decimal system. As I was looking around, I found some metric conversions that we'll see that I'll just leave you with. These are all, I don't know how to, this is a joke. But if you take a look at metric prefixes like mega or kilo or deca, which we'll look at in a few minutes, here are some just silly definitions. 1,000,000 microphones is 1 megaphone. 2,000 mockingbirds is 2 kilomockingbirds. 10 cards is a deck of cards. 453.6 graham crackers is 1 pound cake. 10 rations is a decoration. 100 rations is 1 sea ration. And 10 millipedes makes up 1 centipede. Anyway, so that was another amusing thing that I found for you that will let us get into the metric system kind of gradually. And in fact, if we're dealing with units of length, just to give you some idea, 1 meter, which is the basic unit of length in the metric system, is a little more than a yard. And that really helps you to understand a lot of what we'll be talking about if you remember that. Then we look at prefixes for the metric units. Meta means, for example, a metameter is just 1 meter. But then we can scale up or down. Most of you are familiar with kilometers or kilometers, which is 1,000 meters, which is somewhat short of a mile. Now, you don't find hectometers, which are 100-meter lengths, or decameters, which are 10-meter length, used all that much in everyday discourse or in everyday commerce, but you certainly see kilometers a lot. Similarly, we can go the other way, down decimals, and talk about tenths of a meter, which is a decimeter, hundredths of a meter, which is a centimeter. That's about 1/3 of an inch, and you see that a lot. And we also talk about millimeters, which is 1,000th of a meter, and those are pretty small, really tiny. And so that's how we scale these things up or down. Notice that they go up or down in powers of 10. So if we're going down, we can talk about tenths meters, 100th of a meter. A millimeter is 1,000th of a meter. Just to put things into perspective, let's look at some of the conversions and their approximate English values. For example, let's start with a kilometer. Now that's 1,000 meters. And remember I told you that it was a little less than a mile. It's actually 5/8 of a mile, or 0.621 miles. A kilometer is less than a mile. That means that if you're going any particular distance, there will be more kilometers in that distance. For example, Tucson to Nogales, about 60 miles, about 90 kilometers. 1 meter is about 39 inches, as we said before, about a yard. A centimeter, which is 100th of a meter, is about 2/5 of an inch, somewhat less than an inch. I think of it as a little over 1/3 of an inch. A millimeter, a really small quantity, length, is 1/10 of a centimeter, or 1,000th of a meter. And the most approximate English equivalent unit is going to be something like 1/25th of an inch. Not very much. Let's do some conversions so we see how we can use the idea of a proportion to convert from one unit to another, first within the metric system and then between the metric system and the English system. We want to convert 1.75 meters to centimeters, and we use the definition here. We know that 1 meter is 100 centimeters. Then we can say 1.75 meters is how many centimeters? We can use the proportion 1 is to 100, 1 meter is to 100 centimeters, as 1 3/4 meters, 1.75 meters is to x centimeters. Now we can multiply, cross-multiply as we did with the proportions in the last unit, and I get that x is 1.75 times 100, or 1.75 meters is equivalent to 175 centimeters. You see, it's very straightforward. If we use as one side of the proportion, one of the ratios, the definition of the conversion. 1 meter is equivalent to 100 centimeters. Then on the other side, we can use the information we're given and then whatever unit we're actually looking for. Let's look at another example now. I want to convert 1.75 meters not to centimeters now, but to feet and inches. I do the same kind of unit conversion, but now I say 1 meter is equivalent to 39 inches, as 1.75 meters is equivalent to x inches. 1 is to 39, as 1.75 is to x. I again cross-multiply, and I find that x is going to be 1.75 times 39, or that's going to be 68.25 inches. But you see, we want to convert this to feet and inches. So now I have yet another conversion. I need to change 68.25 inches into feet and inches. Let's do the same thing. First, we convert 68.25 inches to feet. How do we do it? Guess what? With a ratio and a proportion. 1 foot is to 12 inches, as x feet is to 68.25 inches. Again, doing the cross multiplication, then in this case you see we need to divide both sides by 12 to get x by itself. I find that x, 68.25 inches, 1.75 meters, is equal to 5.69 feet. But I'm not done yet, because that 0.69 feet I'd like to express in inches. So I do yet one more conversion. And I notice that I have 5 feet plus 0.69 feet. I want to convert the 0.69 feet to inches. Again, a proportion works fine. 1 foot is to 12 inches, as 0.69 feet is to x inches, and since 0.69 is less than 1, I would expect that x is going to be less than 12. And in fact, when I do the multiplication, the cross multiplication, I find that x is in fact equal to 8.28 inches, and I say that 1.75 meters then is equal to 5 feet 8 inches to the nearest inch, more or less. You see, in this case, I actually used 3 proportions to get the problem solved. But as long as I remember that one side, one of those ratios in the proportion, is just the definition of the conversion, it's straightforward and relatively easy to do. Here we go again. If the distance between Tucson and Nogales is 62 miles, what's the distance in kilometers? First thing I'm going to start with is the definition between kilometers and miles. I know that if 1 kilometer is 5/8 of a mile, then X kilometers, which I don't know, is 62 miles. Now, again, 1 kilometer per 5/8 of a mile, the definition of the conversion between kilometers and miles. And as I did before, I can cross multiply and get the equation that 5/8 x is equal to 62. And I can divide both sides of that equation by 5/8. 5/8 over 5/8 gives me x by itself. Then I have x is 62 over 1 divided by 5/8. If I'm dividing by a fraction, it's equivalent to inverting, taking the reciprocal and multiplying. When I do that, I find that x is equal to 496/5 or 99.2 kilometers. So I've done the conversion between the English system and the metric system. 62 miles is equivalent to 99.2 kilometers. Let's change tack a little bit and look at liquids. A liter of liquid fits inside a box 10 centimeters on a side. That's the definition of a liter. It's how much liquid that you can pour into a box that's 10 by 10 by 10. And we can subdivide a liter into cubic centimeters, tiny little sub-boxes that make up the 1 liter. And a good point, just like we had before, a meter is about a yard. A liter isn't too much off from a quart. It's a little bit more than a quart. Again, a good thing to keep in your head, because if someone is talking to you about liters, you can say, oh yeah, I know how much a liter is. That's about a quart. I get my milk in quarts. I can visualize that. Knowing that, then, we have 1,000 milliliters. And so we can divide the liter down in terms of smaller parts of the liter, and we can also talk about it in terms of its volume. It's 1,000 cubic centimeters, which are tiny little boxes, is equivalent to 1 liter. And you'll see both of these. So a milliliter and a cubic centimeter are used more or less interchangeably. And we can say that 1 cubic centimeter, as I pointed out, is equivalent to 1 milliliter. Or they call, often you'll see it, instead of centimeter cubed, you'll see cc, cubic centimeter. And milliliter is little m, capital L. And a milliliter is, I said, is a tiny amount. It's only a few drops of liquid. Here's a little example. The engine displacement of a motorcycle, and I used a 1982 Goldwing because I happen to have one that looks an awful lot like that, is rated at 1,245 cubic centimeters. And often, if you're dealing with engines that are built not in the United States but overseas, they use a metric equivalent, and they tell you the engine has a displacement, how much space the pistons take up or pump out is measured in liters and milliliters. So it's, or cubic centimeters. So it's 1,245 cc's. What's the displacement of that in liters? What we do is we know that 1,000 cubic centimeters is equivalent to 1 liter. Therefore, 1,245 cubic centimeters is equivalent to x liters. I cross multiply and get 1,000x is 1,245. Dividing both sides by 1,000, I find that in liters, the engine displacement of my motorcycle is 1.245 liters, or 1,245 cubic centimeters. Here's another useful one if you travel. In Mexico, gas is sold by the liter. If I buy 65 liters of gas, I'd like to know how many gallons that is. Now this is an interesting measurement because I can go from liters to quarts, and then once I know how many quarts I have, I can go from quarts to gallons. Let's take the first part. I know that 1.1 quart is equivalent to 1 liter. So on the left, I'll use the ratio 1.1 to 1, and I want to find out how many quarts 65 liters is. So I cross multiply here, and I get the equation that x is 1.1 times 65. Working this out, I find that 65 liters is equivalent to 71.5 quarts. But since we think about gasoline in gallons, I need to change from quarts to gallons. Continuing with the conversion process, we know that 1 gallon is equivalent to 4 quarts. We'll use that as one of the ratios in our proportion. 4 quarts is to 1 gallon, as 71.5 quarts is to x gallons. We, of course, cross-multiply, divide both sides by 4 to get x by itself, and I find that 65 liters of gasoline is equivalent to 17.9 gallons of gasoline. Using proportions like this to do these conversions when you need to do them, for example, liters to gallons if you're dealing with traveling in Mexico where they use liters for different kinds of measurements, is very useful. And with a calculator and knowing proportions, you'll do very well. We're going to switch topics now and go from quantity to talking about mass and weight. And in the metric system, we use kilograms, grams, and if you're dealing with very small quantity, milligrams. Now, a kilogram is roughly 2.2 pounds on Earth. And the reason I talk about on Earth is that, as it turns out, weight and mass, if you're taking a physics class, are different from each other. Mass is an inherent property of matter which deals with its resistance to motion. Weight is actually a force. It's how much gravity pulls on you. Now, it turns out on the Earth, if you double your mass, you double your weight. So that because they're proportional, we use them equivalently. And I'm not going to go into a lot of detail here, but they're not exactly the same thing. Given that caveat, so that I don't have all the science people calling me and saying, "What are you doing?" a kilogram mass on Earth is equivalent to a couple of pounds. If you want to buy a pound worth of meat in a European country or in Mexico, you buy half a kilogram roughly. Or a way of thinking about it, reversing that, a pound is 0.45 kilograms. As I say, it's about half. So that makes it easy to talk about. A gram is about 4/100th of an ounce. A gram is a tiny quantity, or 1 ounce is 28 grams. Now, pounds and ounces, again, don't work with powers of 10. You have to understand how many ounces there are in a pound and so forth, and it's not, there's just a lot to remember. Anyway, let's look at some problems to do some conversions. How many 50 milligram pills can be made from 75 grams of medicine? I have to go from grams to milligrams and then to pills. Let's try this. 1,000 milligrams is equivalent to 1 gram, then X milligrams is equivalent to 75 grams. When I do that, I find that I have 75 grams is equivalent to 75,000 milligrams. But each pill is 50 milligrams. If one pill is 50 milligrams, then X pills is 75,000 milligrams. I can again do that cross multiplication, and I find that I can make 1,500 pills from 75 grams of medicine. And again, you saw that I did this using two different proportions in sequence. This idea of using a proportion is very powerful. How many kilograms of cheese should I buy at a Mexican market to get about half a pound? I've talked about this, but let's do it formally. 1 kilogram is to 2.2 pounds, as X kilograms is to 0.5 pounds. I cross multiply, I work the math out, and I would find that to get half a pound, I would buy a little over 2/10 of a kilogram. Now, suppose we want to talk about area. We can talk about meters and square meters, 1 meter by 1 meter. If I want to talk about square centimeters, then I would have to go 1 meter times 1 meter is 100 times 100. And so 1 square meter, when we do the math, is 10,000 square centimeters. And if we know this conversion, 1 square kilometer is 1 million square meters. And if I know these conversions, then I can work this out. How many square feet are there in a square meter? We have to be careful here. I have to go from square meters to square inches to square feet. Remember, a square meter is 39 inches on a side. Then a square meter is 1,521 square inches. 1 square foot, 12 times 12, is 144 square inches. Now I can use another proportion. 1 square foot is to 144 square inches, as X square feet is to 1,521 square inches. Working this out, again dividing, cross multiplying, then dividing, I find that 1 square meter is going to be 10.6 square feet. And a square yard, incidentally, is 9 square feet, 3 times 3, so I'm not surprised about this. Now, the temperature conversion isn't quite so straightforward, because when you look at the American scale, or we call it the Fahrenheit scale, that has freezing at 32 degrees Fahrenheit and boiling at 212. You might ask, how did they pick such weird numbers, and why did they do it that way? Turns out in the 1700s, when Daniel Fahrenheit invented the scale, he set 0 degrees as the coldest temperature that scientists could produce then. And this was made of a sludge of ice and water and salt, and that was called 0 degrees. On that scale, they took 100 degrees as human body temperature. And of course, we don't agree with that now if we're basing it on the freezing and boiling of water. But at any rate, so between 0 degrees, the coldest temperature, quote, known to man, and human body temperature at 100, on that scale, water froze at 32 and boiled at 212. Well, people said that's kind of crazy and arbitrary. Let's try to do something based on the physical properties of water, but be more reasonable about it. So they developed the Celsius scale, or it's called centigrade, where they say the freezing point of water is 0 degrees Celsius, the boiling point is 100, and we have 100 gradations in between there. Now, the problem in doing the conversions comes because 0 degrees centigrade is equivalent to 32 degrees Fahrenheit. So when one is 0, the other is not. And that makes the conversion formula a bit more complicated than just simply using a proportion. Let's look at how we do a temperature conversion. Here's the formula. To go from Celsius or centigrade to Fahrenheit, we have to take 9/5 of a Fahrenheit degree and then add 32 to it. Remember that 32 has to do with getting back to the 0, the freezing point of water being 0 in one scale, 32 in the other. If we do math the other way, in other words, solve for Celsius in terms of Fahrenheit, we get this. I don't expect you to remember these. If we use it on an exam, you'll be given these formulas. But this is how you convert. Let's look at how it would work. Human body temperature is considered to be 98.6 degrees Fahrenheit. What is body temperature in degrees Celsius? We need to go from Fahrenheit to Celsius for this conversion. So we use the formula. The Celsius temperature is 5/9 of the quantity Fahrenheit minus 32. Here for F, we put in 98.6. Then remember, we need to deal with anything in parentheses first. When I do that subtraction, I get 66.6. 5/9 of 66.6 is equivalent to 5 times 66.6 divided by 9. When I work this out, I see that human body temperature in the Celsius scale is 37 degrees Celsius. Here's another interesting little tidbit. Absolute zero, the temperature which all molecular motion ceases, is minus 273 degrees centigrade. What's the equivalent in the Fahrenheit temperature? Here's the conversion formula we use. We plug in minus 273 for the temperature, and when we work this out, again little by little, we find that the equivalent temperature in the Fahrenheit scale for absolute zero is minus 459.4 Fahrenheit. That's pretty cold. That's as cold as it gets. In other words, it turns out that when you have absolute zero, you cannot get any temperature colder than that. And even more interesting, because this absolute zero is the temperature theoretically at which all molecular motion ceases. The way you make things colder is to pull heat out of it from a higher temperature to a lower temperature. But if there is no lower temperature, you can't pull any more heat out of it, and therefore it theoretically is impossible to reach absolute zero by any means we know of now, according to physical theory.